Vectors. Scalar quantity. A quantity having only magnitude. For example, mass, time, etc. Vector quantity. A quantity having magnitude as well as direction. Now, for example, velocity, displacement. These are vector quantities. A direct line segment is a vector represented by vector PQ, where P is the initial point and Q is terminal point. Zero vector, whose magnitude is zero. A vector, B vector, etc. are zero vector because here initial point and final point or terminal point is same. Unit vector, a vector whose magnitude is 1 unit. It is denoted by A cap. A cap mod is equal to 1. A cap is equal to A vector divided by A vector mod. Like vector. Two vectors are said to be like if they have same or parallel line of support, same direction. Unlike vectors. Two vectors are said to be unlike if they have same or parallel line of support, opposite direction. Equal vector. Two vectors are said to be equal if they have same or parallel line of support, same direction, equal magnitudes. Co-initial vectors. Vectors having same initial point, A, P vector, vector AQ, vector AS, are co-initial vectors because all are having same initial point. Collinear vectors. Vectors having same or parallel line of support, magnitude or direction may not be same. Position vector. Consider a point P, X, Y, Z in this space and Q 0, 0, 0 as initial point. Then OP vector is called position vector of P with respect to O. OP vector mod is equal to X square plus Y square plus Z square under the root. Direction angles. The angles alpha, beta, gamma made by vector R with direction of X, Y and Z axis respectively are called direction angles. Direction cosine. The cosine value of direction angles are called direction cosines. Cos alpha, cos beta, cos gamma. L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. L square plus M square plus N square is equal to 1. Direction ratios. Any three numbers proportional to L, M, N are called direction ratios. If A, B, C are direction ratios, then A square plus B square plus C square is not equal to 1. Vector in two dimensions. Let R vector be position vector of a point P, X, Y. Then R vector can be expressed as X I cap plus Y J cap. R vector mod is equal to X square plus Y square under the root. Vector in three dimensions. Let R vector be position vector of a point P, X, Y, Z. Then R vector is equal to X I cap plus Y J cap plus Z K cap. R vector mod is equal to X square plus Y square plus Z square under the root. Here I is the unit vector along X axis, J the unit vector along Y axis, and here also I is the unit vector along X axis, J is the unit vector along Y axis, and K cap is unit vector along Z axis.